Experiences are what people love the most about travel. That's why they love Viator. They have over 300,000 bookable experiences and something for everyone. Plus, their travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. Download the Viator app now and use code Viator10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hi there, and thank you for joining us on the Space Nuts podcast. My name's Andrew Dunkley, your host, and with me as always is astronomer Fred Watson. G'day, Fred.
G'day, Andrew. How's it going over there in the central west of New South Wales?
It's getting warmer. The season is changing. The pollen is flying. My eyes are watering. All is as good as it can be this time of the year, which is not real good actually. But they've got drugs for that now, so it's we're all fine. We are so desperate for rain. There is the most severe drought that we are suffering at the moment, and it's having a massive economic impact on farmers and all the fringe businesses that rely on farming. And of course, the towns are suffering. And we're already seeing people sell up and leave, which is very, very unfortunate. We thought that was the worst it could get during the millennium drought. But then this one, they say, is much worse and much more widespread. The entire state of New South Wales is now considered in drought in some form, but sadly we're at ground zero when it comes to the effect of this drought. We're in the worst patch of the state, so not good at all, really. We've just got to struggle on. But that aside, you and I are going to talk about something completely different, and the Hayabusa 2 mission has seen success. We did talk about this a few weeks ago, but things have happened pretty fast. This is the Japanese mission to try and land on an asteroid. In fact, I think they were plopping a couple of rovers down on there, so we'll see how that went. We'll also look at New Horizons. That's a probe that's been into the outer reaches of our solar system, and it's about to visit another body that I'd never heard of until you told me the name of it, Ultima Thule, which is, I'm guessing, some kind of rock out there. That it's going to do a flyby fairly soon anyway. And variations in light temperature. A question from Petra about why in some cases red is hotter than blue and in other cases blue is hotter than red in the spectrum. So we'll get to that. That's a fantastic question and one she's obviously put a lot of thought into. But firstly, Fred, Hayabusa 2, successful mission?
So far, yeah, it's going really well. I mean, this is, we have, as you said, spoken about it recently. So this is a bit of an update. As we speak, the spacecraft is in orbit around the asteroid Ryugu, which is formerly known as 1999 JU3. And it's a carbonaceous asteroid, very common type of asteroid, but of a kind that we think contains some of the building blocks of the solar system, the most, if you can put it this way, the most pristine matter in the solar system. So it's lots of stuff. There's probably ice there. Or there might be organic compounds, the carbon-containing compounds that we think were the building blocks of life. All of that stuff, there'll be minerals there as well. And so the idea of Hayabusa 2 is to study this asteroid to within an inch of its life, and more than that, bring some back to the Earth, which is, the big plan. And of course, it follows up with the Hayabusa 1 mission, which was more than a decade ago now, which was nearly successful, visited another think it was Ikutawa or something like that, the asteroid it visited, and did actually bring a sample back, but it was a long and difficult process. So with the new Hayabusa spacecraft, what we have at the moment is the main spacecraft in orbit around the asteroid, and two little rovers on its surface, which are known as Minerva. Minerva is the sort of generic name for all these rovers, but there's actually rather a lot of them. So there are two rovers at the moment, both of which are called Minerva 2-1. That's the container that deployed these two rovers. I think they also have technical names of Rover 1A and Rover 1B.
Okay.
They were deployed a few days ago. They're JAXA rovers. They're not so much rovers as so much as hoppers, because they've got rotating masses within them. A bit like, that thing that makes your mobile phone buzz,
Yes.
which is a rotating mass. It's the same sort of thing. So, but these are relatively heavy masses. Well, the whole thing's only a few kilograms, but it's actually a little more than a kilogram, each one of these things. But they contain those rotating masses that basically bounce them off the surface. Because the gravitational field of the asteroid is so long, so low. I'm losing the power of speech here. I'm so excited about it. Because the gravitational field of the asteroid is so low, one hop lasts for about 15 minutes.
No way.
They
Really?
gently land back on the surface.
15 minutes?
Yeah. It's great stuff.
That's amazing.
So the Minerva 2 rovers, Rover 1A and Rover 1B, have basically cameras on board. They've got a stereo camera, a wide-angle camera, and actually thermometers. And they've got solar cells to provide the power. The great thing is, these things are not much bigger than a loaf of bread. If you imagine one of these circular loaves of bread that we occasionally get to eat, maybe 20 centimeters across and 6 or 7 centimeters thick, that's the size of one of these.
You're thinking of a cob loaf, I think.
A cob, that's the word I'm looking for.
Yeah.
Yes, they should have called them Cob 1A and Cob 1B.
They should have. I'm really disappointed to see that the Japanese Space Agency's taken a leaf out of NASA's book and gone with the lame name department. But anyway.
Well, yes, that's right. The bottom line is that they're currently working. They're working well. They're sending images back. And remember, the spacecraft it's about 200. If I remember, it's about 280 million kilometers from Earth. It's very, very distant at the moment, and that seems to be all working well. There isn't. It's kind of extraordinary that the stuff that's going on up there when the rovers were dropped onto the surface in their container, the orbital height of the mothership Hayabusa 2 over the asteroid was 55 meters. So that's a pretty close approach, 55 meters. It tells you that these the mission controllers for this really know what they're doing. It's kind of nominal positions about 20 kilometers away from the asteroid, but bringing it down to that 55 meters is quite astonishing. And each hop of these little rovers is roughly 15 meters or so, and they'll do it until their solar panels fail. So they've got, I think these things are probably set to be hopping all over Hayabusa 2 for quite some time.
So is it just a general sort of see what we can see kind of mission, or do they have a specific target in mind?
They do. They've got lots of targets. So these little Rover 1A and Rover 1B are just the precursors. There is another container which is called Minerva 2-2, and that holds the rover number 2, and that's a rather bigger rover. It's got the sorts of stuff that you might expect. It's got thermometers and cameras. It's got stuff that will allow it to sense the amount of dust that there is coming up from the surface of the asteroid. And once again, it's got this hopping mechanism. Apparently, there are 4 hopping mechanisms in the second rover. And then there's another one, which is a German aerospace contribution, along with the French Space Agency. And this is called MASCOT, which is the Mobile Asteroid Surface Scout. That's got a much bigger set of instrumentation. It doesn't have solar panels, however. It's just got a battery. It's got camera, infrared spectrometer, magnetometer and radiometer, and all of that sort of thing to tell us more about the surface of Hayabusa. Sorry, of Ryugu. The spacecraft itself, however, this is the mothership, and rather than the 4 rovers we've just been talking about, the mothership will itself, at the end of the mission or late in the mission, and I think that's going to be about the end of next year, will basically land on the surface of the asteroid with a sort of a horn, which will touch the surface, and then you fire a bullet into the surface, and what happens is you get a whole lot of stuff which is released from the surface, and it's collected by the horn. And that then comes back to the Earth, landing sometime in 2020. It is really an extraordinary mission, very, very ambitious, and we keep our fingers crossed that we might have bits of an asteroid coming back to Earth round about December 2020.
You've got to hand it to the Japanese when it comes to ingenuity. That this whole concept, the bouncing rovers and the touch and go landings, and the way they're scooping up bits and pieces is just extraordinary. And I think dumb things like, how did they keep the battery charged for the trip so that that 4th rover would operate? Because out in the depths of space, it's cold, and we know cold weather basically drains batteries. So they must have had a trickle charge going all the way there.
Yeah, they do. The mothership itself, Hayabusa 2, has solar panels and is kept fed by sunlight, basically. It's great stuff.
Fantastic. And so as long as there's sunlight, these rovers should continue to hop around. So we should get a lot of data in the not too distant future. I know they've already sent back a photo from Minerva 2-1, although it's not the greatest photo, but it is the first photo, I believe, which they've published on Twitter. So we can get a bit of a glimpse of what they're up to, but hopefully they'll get some better quality pictures and ultimately some bits and pieces of asteroid to bring back to Earth. And what we'll learn from that, well, that remains to be seen, but could be exciting.
I hope it will be.
All right, we'll probably hear more about that in future episodes of Space Nuts. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/ space. That's TRYEXPRESSVPN.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, from one deep space mission to another, this is the mission of New Horizons, which has already done incredible things and has been up there for 12 years or so now, from what I remember. It's done a flyby of Pluto and one of the others, was it Charon, I think?
Yes.
Yep, and now it's off to Ultima Thule. And
Yeah, which
I'd never heard of Ultima Thule. Where have I been?
No, you and I have spoken about this before, but we've given it its proper name, which is MU69.
Ah, right. Now it all...
Your old friend MU69.
I like Ultima Thule much better.
Yeah. So the word means something like the most distant place or something of that sort. I mean, Ultima clearly is the ultimate, and Thule is something remote, I believe, from my poor knowledge of classical languages. Anyway, it's on its way there, and we've kind of known about this since 2015 when New Horizons did its epic flyby of Pluto and the Pluto satellite system, including Charon, as you mentioned. It was a stupendously successful mission, and everybody's hoping for the same thing when the spacecraft flies by. I'm going to give it its proper name, MU69, in the very early next year. In fact, it will probably be at its closest almost on the dawning of New Year's Day. It depends on what time zone you're talking about. In Australia, we should hear about it sometime on New Year's Day. The reason why it's in the news is that there's been a bit of an announcement about it and some interviews by its chief or its mission principal scientist, Alan Stern, who you might remember. I think we spoke about this. I met him last year, was it? Yeah, maybe earlier this year. An extraordinary man and a very, very nice character to speak to. Very modest, Mr. Pluto, really. But he's just an ordinary scientist, keen to find results and keen to tell people about them. Not somebody who's put himself in an ivory tower because of his extraordinary position. He's just a great bloke. And I hope that he meets with success again when the spacecraft flies by MU69. So the things that we're learning from the discussion with Alan Stern is that the plans for this encounter, and apparently it will be effectively a repeat of what happened with Pluto. So, and you might remember, Andrew, that what they did was they had to shut down the spacecraft's communications with the Earth during the encounter because they had to essentially turn the spacecraft round, swivel it round so the cameras were pointing towards Pluto, and then sort of pan along all that and gathering data with all the festoon of instruments that are on the spacecraft, and then once the encounter was over, turn the spacecraft back so that the high gain antenna is pointing back at the Earth and send all the data back. And it took quite a long time to get the data fully back. And it's even more true now with this object, which is rather further away than Pluto, about 500 million kilometers further away. In fact, Pluto's about 6 billion kilometers. This one's about 6.5 billion kilometers. It's an icy asteroid. We don't even really know how big it is. You can only see it as a point of light with the telescopes that have been used to pick it up, and so you've got to sort of estimate what its surface reflectivity is to guess what its diameter might be. It's probably only really a few meters, maybe a kilometer at the most, but not a large object. We really don't know what we'll find. It's probably a fairly typical denizen of the of the outer asteroid belt, that belt of objects that we sometimes call the Kuiper belt, named after Gerard P. Kuiper, one of the great astronomers of the 1950s. We know that that's got this whole region. There's more than 1,000 known, and there are probably many millions altogether, of icy debris left over from the formation of the solar system, of which Pluto and a few other big ones are the biggest members. I think we will learn a lot. The flyby will be at actually about 3,500 kilometers, which is closer than New Horizons' passage round Pluto.
But a much smaller target. So
it's a smaller target,
it's probably a bit more tricky to get the sort of information they're looking for and get the cameras on it.
That's correct.
Yeah, the targeting's going to have to be fairly precise, I would imagine.
Exactly. They've got to get this right, and I'm sure they will. They certainly did with Pluto. Just to perhaps explain that a bit further and correct something I just said a few minutes ago. Pluto's a bit more than 2,000 kilometers in diameter, whereas Ultima Thule is more than I said. I said of order a kilometre. It's actually about 37 to 40 kilometres, something of that sort. Yeah. So it's a little bit bigger, but it still is
quite small.
A small target when you're 3,500 kilometres away from it. So everything's got to work, and I'm sure it will.
I'm kind of thrilled that New Horizons was launched in 2006. They didn't find this asteroid until 4 years ago.
Yeah, that's
and
right.
Yet an existing mission can be retasked to go and have a look at it. I think that's awesome.
That's right. I think if you remember, what happened was when the flyby of Pluto was completed, they identified 3 possible targets out there in the Kuiper belt. An MU-69, as you said, it was discovered in 2014, so it was not known when the spacecraft was launched. When they chose that one, I think it was because it's the easiest one to get to, and perhaps in some ways the most interesting one. So they had to do a course correction on the other side of Pluto to point the spacecraft in the direction of this object. And it's on track. You know, all the evidence is that it is actually perfectly aligned, and gravity lets you do that because it's so well understood, but perfectly aligned with MU-69. The things that I think concern Alan Stern at the moment are to do with the fact that the spacecraft is now going to be 3 years older, 2.5 years older than it was when it flew by Pluto. So that means that the little nuclear power plant that they've got on board is delivering less power because it does actually decay. This is the plutonium generator, the RTG, the radioisotope thermoelectric generator. Yeah. The plutonium fuel in that just gradually loses its oomph. It clearly still has enough to power the spacecraft, but it might be, it might be a bit of an increased risk factor in when they take all the risks into account to decide what to do. In terms of pointing it.
But, what they've achieved so far has almost been a flawless mission, and I don't recall too many missions in deep space going so brilliantly. I suppose the Voyager missions are great examples of success stories, but
yes,
this one's going along pretty well along the same kind of path. So even if they kind of don't hit the jackpot with MU-69, it's good to have a go. I mean,
yeah,
how Aussie
absolutely.
is that? Have a crack.
It is. It's it's got a true Aussie spirit on board.
All right, we will watch that one and hopefully have some startling information about this little rock out in the edges of our solar system early next year, Fred, I imagine.
Sounds good. Yeah.
All right. You're listening to Space Nuts, Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
Finally, Fred, a question from the Peanut Gallery. Get it? Space Nuts. Okay, this one from Petra Drudd. Petra, you're not a peanut. Thank you for answering my first question. I have another. William Herschel discovered infrared light by measuring the temperature of a rainbow. He found the temperature increased from blue the lowest, to red, the highest. However, when we measure the temperature of stars, we say the blue stars are hotter than the red stars. I'm hoping you can explain why these two ways of measuring light temperature are different. So in a rainbow, blue is the coolest, red is the hottest, but in stars, it's the other way around, is what she's saying, and she's asking why.
That's right, and it's a great question. So we tend to refer to the rainbow as a spectrum, and we know that spectrum of light, ranging from red right through to violet at the other end of the spectrum, we know that spectrum is just a small part of a much bigger set of radiation, which we call the electromagnetic spectrum. And if you kind of go beyond blue, you get to ultraviolet light. You go beyond that, you get to X-rays. You go beyond that, you get to gamma rays. And at the other end, if you go beyond red, you get infrared. And if you go beyond that, you get microwaves. And if you go beyond that, you get radio waves.
And they're all forms of light.
Yeah, they're all forms of light. It's the same sort of radiation. That's right. It's an electromagnetic radiation. It's one of the best understood things in physics, probably. So Herschel's experiment was exactly as Petra says. He got light from the sun, passed it through a prism, and made a spectrum of the sun, a rainbow of the sun, and used a thermometer to measure the temperature along it, and found really not much in the visible part, not much heat there. But when he put his thermometer beyond the red end of the spectrum, where he couldn't see any radiation, he found the thermometer went up in temperature. And that was because the thermometer is being heated by infrared radiation. So the thermometer itself is telling you about the particular radiation you're receiving. And that is true. Infrared is essentially radiant heat. So it's a property of that particular part of the spectrum that the thermometer responds to, and it doesn't respond to other parts of the spectrum. If, however, and he clearly didn't do this because he didn't know about them, if Herschel had, instead of been using a thermometer, had used a photoelectric device like a photoelectric cell like you have to detect the amount of light for a camera, he would have found the blue light would have given him the biggest reading. And it's because blue light has more energy in it than red light or infrared light. So a detector that's sensitive to light rather than heat will respond much more to blue light than red light. So what I'm saying here is that the fact that the thermometer showed up those differences in temperature, which peaked in the infrared beyond the red end of the spectrum, that's more a property of the thermometer itself. It's a device that measures temperature, not a device that measures energy. We do have devices that measure the whole energy of something, and they're called bolometers. It's a very odd name, but a bolometer is not it's kind of independent of what region of the spectrum you're looking in. It will tell you the whole picture. They're very unusual and rather interesting technical devices. So just to recap on that, the bottom line is that as you go bluer in the spectrum, you actually are looking at higher energies. And when you get to ultraviolet, of course, that's the energy that burns our skin in sunburn. And then beyond that to X-rays and gamma rays, they're very high energy radiation. So now turning to stars, the blue stars are hotter than red stars because they've got more energy. Basically, it means that the energy that they are emitting peaks in the bluer region of the spectrum rather than the red end of the spectrum, because their intrinsic temperature is very high, and that's to do with the overall energy of the star. So red stars are the cooler ones, unlike the thermometer experiment that Herschel did.
I suppose you can also look at it from a perspective of Herschel was looking at a spectrum of a single star, whereas looking at different stars, you've got different combinations of fuels, you've got different sizes and makeups, and it's not the same situation, really.
That's true, but the most important property of a star is its temperature, and that alone determines what its color is. So And that's sort of been known since the latter years of the 19th century. The colour of the star is really directly related to temperature, and it comes about, and you can sort of do a thought experiment here. The star itself is behaving for these purposes like what we call a black body, and a black body is a technical term for something that has no reflectivity. So if you imagine a lump of dirty iron or something like that, you can regard that as a black body. When it's at normal room temperature, it is actually emitting infrared, but we can't see that. But if you start heating it up, first of all, it goes red at temperatures in the order of 400 or 500 degrees. Then it starts getting white. We call it white hot. And if you heated it more, it would be going blue. And that's really relating to the way the stars are. They're like a lump of iron. The cooler ones are red and the hotter ones are blue.
I suppose you can also equate it to a gas flame. The blue part of the flame is hotter than the red part of the flame.
You can, but that's another different process.
Is it really? Well. Oh, gosh. Yeah. Okay.
But it's a nice one. It is certainly true that the blue part is hotter. But the point is that the gas flame is not a black body. It's got other things in it as well. Whereas a star effectively is just a black body, a bit like a lump of iron.
So, hopefully, Petra, that sorts out your question.
Dear, I don't think. That's not our best. I don't think that was our best moment, Andrew. I think that was not a good explanation, but that's the way it is.
Yes. So there you have it, and hopefully that covers the answer for you, Petra. Fingers crossed. But thank you for the question. We do appreciate it, and we've had plenty lately. It's just consuming every day. In fact, that I'm seeing questions popping up mainly through our Facebook page, but they're all well thought out, and they keep us going, don't they, Fred? They're very bright.
They're great. It's great questions, yeah, and we're delighted to have them. It's fitting them all in. I think before too long we'll have to have another whole episode devoted to questions.
Maybe so. Yes, yeah. We might have to do that every so often so that we can catch up a bit, because we've fallen behind again already. Some of them we do answer online rather than on the podcast, but yeah, there's a few there that really tease our brains, especially Fred's, and he likes to have a bit of a go at them. So thank you, Petra, and thank you everybody for contributing to Space Nuts. We do appreciate it greatly. And thank you, Fred. Nice to catch up with you yet again.
Sounds good, Andrew. I also enjoyed that, and I hope we can do it again soon.
I hope so, yeah, indeed. Maybe next week.
Maybe.
Fred
Good
Watson, astronomer, joins us every week on Space Nuts. And from me, Andrew Dunkley, thanks for listening. We'll catch you next time.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.